Welcome to math classes. Today we'll learn about the class 12th, chapter 5 from NCERT book. Okay, this is about limits, continuity and differentiability. Okay, since we are started with the limits and then differentiation in class 11th book actually, I want to continue this chapter because this is a continuity of the previous two chapters. Then after this you can also learn applications of differentiation, then complete differentiation and limits will be a complete one. Okay, but those students who are preparing for the Telangana board or any state board, probably you may not have this chapter in the 11th class exams. Okay, so yeah, watch out for those things. Okay, and in this video, okay, especially even though complete chapter is about limit, continuity and differentiability, in this video we will learn only limit, continuity. Okay, differentiability I will make another video because this is a very big chapter. Okay, and the exercises are huge. Okay, so what we will cover in this? Okay, this is, as I said, NCERT class 12th chapter 5, limit, continuity and differentiability. We will understand limit, continuity and discontinuity, algebra of continuous functions, and then exercise 5.1. That's all we will stop in this video. Okay, we will continue another video with the differentiability and other exercises. Okay, so let's understand the continuity. Continuity means, in a simple, very simple terms, if you want to draw a curve or a graph, okay, without lifting pen, if you can draw it, then it is a continuous function. Okay, if you see the example here, the graph given here, if you want to draw this line, you have to draw one line here and then jump to this point. Okay, your pen should jump to this point and draw another line. Okay, so you are jumping here, correct? Then this is not continuous. Okay, a continuous one is like a sinusoidal wave, like a cos wave, okay, like a straight line. Okay, it can be any other parabola. Okay, so these are the continuous lines. Okay, so this is the basic definition of continuity in a graph. Okay, if you look at the function here given here, this is nothing but f of x equal to 1 if x it is less than 0, x is less than or equal to 0. It is equal to 2 if it is x is greater than 0. That's why you have two lines here. Okay, and there is a gap between 1 and 2 on the x values. At 0 you have two values actually. Okay, there is a jump here. Okay, now if you take limit, you already learned limits. If you take limit at 0, there is a jump, right? Limit extends to 0 plus, you get 2 as the value, extends to 0 minus, you get 1 as the value. So both are not equal, so limit doesn't exist. That means it is not continuous. Okay, now let's understand what is the rule for continuity. Okay, the mathematical definition is, a function f is continuous if at x equal to c, limit extends to a, f of x equal to f of a. That means limit should exist at x tends to a and which should be equal to f of a. Okay, when limit will exist? Limit will exist for two conditions. Its left hand limit should be exist, right hand limit should exist, and both should be equal. Only then limit exists. Correct? Then the definition of continuity is, okay, continuity, the left hand limit should exist, right hand limit should exist, and both limits should be equal to f of c. Okay, even if they are not equal to f of c, then also it is not called continuous function. Okay, example here, it is a continuous curve here, and at c, okay, left hand limit, right hand limit, both pointing to the same point, and also f of c also is here. Okay, so this is called continuity. In case any one of them fails, it is called point of discontinuity at that point, at the given point. The given point, in this case c, is called point of discontinuity. Okay, let's understand more actually, okay, about this. Okay, so let's take example, f of x is m for x is less than a, f of x equal to n for x greater than a. Okay, and f of x is not defined. F of x is not defined. Correct? There is no f of x. It is only you have for x less than a, x greater than a, but at x equal to a, it is not defined. Okay, so if you consider this one, limit extends to a minus, f of x is m, limit extends to a plus, f of x is n. Both are different. Actually, it is not a continuous function, and even limit also does not exist. Okay, and even f of x is also not defined. Okay, so all the cases are negative. So this is not a limit, not even continuous. Now let's see the next example. Okay, let's say f of x exists. Okay, f of x equal to m for x less than a, that is this line. F of k equal to k for x is equal to k, that is here. Okay, f of k is k for x equal to a. Okay. Now f of x equal to n for x greater than a. That is this line. Okay. Now if you take LHL and RHL, LHL and RHL are not equal. LHL is m, RHL is n, but f of a is k. All three are not equal. Okay. That means limit is not defined. First of all, forget about continuity. Continuity is next. Okay. First is a curve should be a better curve is when limit exists, and more better curve is when it is continuous, and more better curve, more smoother curve is when you have a differentiability. Okay, this is the order basically. Okay, so here limit itself does not exist. Now let's see the next. Okay, so f of x equal to m for x less than or equal to a, less than or equal to a. That means f of x at x equal to a is m. Okay, f of a is m. Okay, and f of a equal to m for x less than a also, and f of x equal to n for x greater than a. Okay. Now in this case, LHL equal to f of a equal to m. Both are same, but RHL value is different. RHL is m. That means limit is not defined because LHL is not equal to RHL. Limit is not defined. Okay. So this is also we cannot even think about continuity here. Okay. Next. Okay. Now f of x equal to m for x is not equal to a, and f of x equal to n for x equal to a. Okay. Now in this case, LHL and RHL are both are m. Okay, that means LHL equal to RHL, which is m. Okay, which means limit exists. Okay, I will say limit extends to a f of x equal to m. Okay, but limit extends to a f of a is okay. This is not correct. Okay, f of a equal to how much it is n. F of a is n, which is not equal to this value. Okay, so even though limit exists, the limit is not equal to f of a. Okay, so which means limit exists but it is not continuous. Okay, now the last one where we have LHL equal to RHL and which is equal to f of a, f of x equal to m for x equal to a. Okay, and a limit exists, so this is called continuous. You should have a limit exists at that point, and then at that point the limit also should be equal to the function value at that point, that is f of a. Okay, so this is what is continuous. Okay, this is the case we are going to discuss mostly in this video. Next, simple examples. Let's take f of x equal to 2x plus 3. This is a continuous, it's a straight line. Okay, you can draw a straight line without lifting pen, we know it, so it is a continuous function. Okay, and at x equal to 1 I said, okay, at any point basically it is continuous. There is no breaks for this function. Similarly, f of x equal to x square. Okay, f of x equal to x square is this graph here. Okay, this is a straight line 2x plus 3. This is f of x equal to x square. It's a parabola. Okay, upward opened upward parabola, and minimum value is 0. Okay, but if you see, you can draw this curve without lifting your pen. Correct. So this is continuous function. Okay, at every point, even including 0. Even though at 0 there is a direction change for the curve, but still at 0 it is continuous. Okay, now f of x equal to absolute x. Okay, if you draw the graph, it looks something like this, and see, you can draw this without lifting pen. Correct, like this. So this is continuous at x equal to 0 also. Okay, it is continuous. It is not differentiable. When we come to differentiation, we'll understand it is not differentiable because there is a spike, but it is continuous. Okay, so it is continuous. Now f of x equal to 1 by x. That graph looks something like this. Now, do you think you can draw this graph without lifting pen? Definitely no. That means there is a discontinuity, and that discontinuity is at the point 0. Okay, at x equal to 0, this f of x is not defined. It will become 1 by 0, which is infinity, right? So this is discontinuous. So we will call the function 1 by x is discontinuous at x equal to 0. Okay. So one learning from this one is polynomials and modulus functions are continuous in their own domain. Okay, in their domain means, okay, let's say if this absolute x is in the denominator, then it should not be equal to 0. Correct. So in their domain they are continuous. Okay, if you consider f of x equal to 1 by x also, the domain of this function does not include x equal to 0, because they know that this function is not defined for x equal to 0. So in its domain it is continuous, but at 0, if you include us at 0, is it continuous? It is not continuous. Okay, next. Okay, some more examples we'll see. Okay, why 1 by x is not continuous? If you see limit extends to 0 plus 1 by x is plus infinity, that is RHL, and LHL is minus infinity, and f of x equal to 1 by x is not continuous because LHL is not equal to RHL, so limit does not exist first of all. Okay, now second one is, you look at this one, f of x equal to x plus 2 for x is less than or equal to 1, f of x equal to x minus 2 for x is greater than 1. Okay, if you individually see, this is a equation of a line, correct? So this is continuous in its domain, that is x is less than or equal to 1, it is continuous. X minus 2 also continuous for x greater than 1. Okay, this is x plus 2, this is x minus 2. Both individually are continuous, but if this is a single function, definition is like this, then at 1 there is a jump, at 1 there is a big jump, the line is like this, and then there is a jump here, and then line, you're drawing the other line, correct? So this is discontinuous at x equal to 1. And similarly, if you look at the GIF or step function, f of x equal to GIF of x, that is greatest integer function. Okay, at this is between two integers, this is a straight line. Okay, but at the integer value, it will have a jump because LHL will be a lower integer, RHL will be higher integer, correct? So there is a jump at every integer value. So the GIF of x is discontinuous at every integer value. Okay, so this is what you should understand about the limits continuity. Okay, then the algebra of continuous functions. Okay, we have learned it in the limits also. If f and g are continuous at x equal to c, then f plus c, f plus g, f minus g, f into g, all are continuous at c. F by g, f of x divided by g of x also continuous at c if only condition is g of c should not be equal to 0. Okay, if you ask me at g of at c equal to 0, at x equal to 0, is this f by g is continuous? Definitely no. Okay, because it may be equal to 0. If it is equal to 0, if g of c is equal to 0, then at that point this f by g is not continuous. Okay, so polynomials and rational functions are continuous. Okay, whatever summation you do. Okay, next, composition of continuous functions. Okay, this is a very simple thing. If g is continuous at x equal to c and f is continuous at g of c or at c, okay, then f of g of c, f of g of x is continuous at x equal to c, which means, okay, forget this is c actually. G is continuous at x equal to c, f is continuous at x equal to c. Then f of g of x is continuous at x of c. Example, let's say f of x equal to sine of x square. So I will take g of x as x square, f of x as sine x. Okay, so my f of g of x will become nothing but sine of x square, and this is also continuous because individually x square is continuous, sine of theta also continuous. Correct, sine of x or sine of theta is also continuous. Since f of x is continuous, g of x is continuous, f of g of x also continuous. Okay, similarly, f of x equal to absolute 1 minus x plus absolute x is continuous because if you separate them as two independent, this absolute as separate, this will become 1 minus x plus absolute x, which is continuous. Okay, and absolute value of this one, which is also continuous. Okay, so you can use this composition method to make sure that continuity, to verify the continuity at a given point. Okay, next. Yeah, let's do the exercise. This is the all theory that is there for limits continuity. You can form several questions. Okay, several questions, and JEE main, this is one of the favorite topics actually, limits and differentiability and integration. So you have to learn and practice more problems. So let's do this exercise. Prove that the function f of x equal to 5x minus 3 is continuous at x equal to 0, x equal to minus 3, and x equal to 5. Okay, so I will do some of the problems, and most of them you have to solve it same way. Okay, and a few of them I will just explain the method and then go ahead. Okay, but you can see the problem, you can solve it and cross check the answer here. Okay, let's see. We know that 5x minus 3 is a simple polynomial, so obviously it will be continuous at all the points, right? Only thing is the method I will show you how to do it. Let's take x equal to 0. Okay, so at x equal to 0, RHL equal to limit x tends to 0 plus 5x minus 3. Okay, and if I substitute x equal to 0 plus, or I can also say this, limit h tends to 0, then x 0 plus h, x is 0, right? So 0 plus h, okay, minus 3. This is how you should do for RHL. For LHL, you will do 0 minus h. Okay, x tends to 0, so 0 minus h I will take and then substitute it in the same. Okay, so h tends to 0, 5 times 0 plus h minus 3. Okay, which is minus 3 basically, because h tends to 0. If I substitute 0 here, it will become minus 3. And LHL is nothing but limit x tends to 0 minus 5x minus 3, because same function, right? So this is nothing but 5 times 0 minus h into minus 3, which is also minus 3. So LHL equal to RHL, which is minus 3. And then f of 0 also, f of 0, if I substitute 0 equal to x equal to 0, then it will become minus 3. So this is also minus 3. So LHL equal to RHL equal to f of x. So it is continuous at 0. Similar way you can do for minus 3, minus and x equal to 5. All are continuous. You will get the answer. Okay. Then examine the continuity of the function f of x equal to 2x square minus 1 at x equal to 3. You will do exactly similar way as given here. RHL is nothing but limit x tends to 3 plus 2x square minus 1 r, which is equal to limit h tends to 0. Okay. Basically, it is x plus h. Okay, and x is x is tending to 3, so 3 plus h. Okay, so 2 times 3 plus h whole square minus 1, which is nothing but if I substitute h equal to 0, I'll get 9 times 2, which is 18, 18 minus 1, 17. Okay, similarly, LHL is nothing but limit x tends to 3 minus 2x square minus 1, which is nothing but limit h tends to 0, 2 times 3 minus h whole square minus 1, which is 17 again, and f of 3 also 17. So LHL equal to RHL equal to f of x, so it is continuous at x equal to 3. Okay, but we know already it is continuous because it's a polynomial. 2x square minus 1 is a polynomial, correct? Okay. Similarly, you can do other problems. Okay, f of x equal to x minus 5. This is a polynomial function, so it is continuous. Okay, for all real numbers, we know it. Okay, now f of x equal to 1 by x minus 5. X is not equal to 5. So the domain of function is already r minus 5, correct? The domain is r minus 5, then I should check continuity only at the point which is r minus 5 points only I have to check. I need not check at 5. Okay, so at 5 it is discontinuous, but if I remove 5 because domain is r minus 5, okay, at r minus 5 this function is continuous. Okay, limit x tends to c, suppose. Okay, and 1 by x minus 5 is nothing but 1 by c minus 5, which is f of c. Okay, f of c basically. So this is continuous for r minus 5. The x equal to 5 doesn't come into picture at all. Okay, next. F of x equal to x square minus 25 by x plus 5, where x is not equal to minus 5. So if x equal to minus 5, we are not sure, right? This function may not be defined. But if x is already given not equal to minus 5, this function is always continuous. Okay, and you can simplify it. F of x is nothing but x minus 5, because you can cancel x plus 5 and x plus 5. So this is a simple polynomial which is always continuous. And so this is continuous for the given domain, that is r minus 5. F of x equal to absolute x minus 5, where x is not equal to 5. Okay, even if x is equal to 5 also, it is continuous, but it is defined as x is not equal to 5. So you define your function f of x equal to x minus 5 for x greater than 5, and minus x plus 5 for x less than or equal to 5. Since we are only looking at x not equal to 5, I think we can put it less than here. Okay, individually both are continuous polynomials, so both are continuous. Okay, so we can say that absolute x minus 5 is continuous for all real numbers. Okay, next. Function f of x equal to x to the power of n is continuous at x equal to n, where n is a positive integer. Okay, so this is simple. N is a positive integer he has given, so nothing much to do. We already know polynomial is a continuous function, and x power n is a polynomial, so it is continuous and its value is f of n. Okay, at n its value is f of n. Yeah, f of x is defined as x for x less than or equal to 1 and 5 for x is greater than 1. Is it continuous at x equal to 0, 1 and 2? Okay, so simple thing. At x equal to 0, which equation you will take? At x equal to 0, f of x is just x. Okay, only x. So it is a straight line equation. So this is a continuous. We know it. Okay, and at x equal to 1, okay, this is where you will get a condition. You have to check LHL, RHL. LHL is nothing but limit x tends to 1 minus f of x. 1 minus, I have to take f of x as x, correct? So that is nothing but 1, okay? But RHL is limit extends to 1 plus, okay? That means at 1 plus, the f of x is nothing but 5. So RHL equal to 5, correct? At greater than 1, which is RHL, that is nothing but 5, okay? So LHL is not equal to RHL, so it is not continuous at x equal to 1. And at 2, I have only one equation. At x equal to 2, f of x is nothing but 5, which is a constant function. So limit extends to 0, f of x is nothing but 5, which is equal to f of 2. So this is continuous at x equal to 2. So overall, this is continuous at x equal to 0 and x equal to 2, but not continuous at x equal to 1. Okay. So next, similarly, we will do this one also. 2x plus f of x is defined as 2x plus 3 for x less than or equal to 2, 2x minus 3 for x greater than 2. Okay. So at 2, what happens? At 2, LHL is nothing but 7, RHL is nothing but 1. So both are not equal. So it is not continuous at x equal to 2. Okay. Find all points of continuity for f of x, which is defined as absolute x plus 3 for x less than or equal to minus 3, minus 2x if it is between minus 3 and 3, if it is 6x plus 2 if it is greater than or equal to 3. Okay. So if you see definition individually, okay, for x less than minus 3, f of x is nothing but minus x plus 3. This is a polynomial and we know it is continuous for all x less than minus 3, correct? And at between minus 3 and 3, f of x is defined as minus 2x, which is again polynomial. So between minus 3 and 3, it is a continuous function. And x greater than or equal to 3, it is nothing but 6x plus 2. So it is a polynomial. So it is continuous, we know. So only thing is we need to check the continuity for boundary values, which is x equal to 3 and x equal to minus 3. So first let's take x equal to minus 3. At minus 3, uh, less than minus 3, that is x tends to minus 3 minus slightly less than minus 3 is nothing but absolute x plus 3, okay, which is nothing but absolute x, right? This is, so it will be 3 plus 3, which is 6. RHL is limit extends to minus 3 plus, which means definition is minus 2x, okay? So minus 2x, if I substitute, then it will become 6. And f of minus 3 also, f of minus 3, which one will take? We'll take this equation, correct? F of minus 3 also 6. So at minus 3, it is continuous, okay? But at x equal to plus 3, okay? Now limit extends to 3 minus, so 3 slightly less than 3. So this is the equation we'll take, minus 2x, okay? Now this is nothing but limit is LHL is minus 6. RHL is limit extends to 3 plus. 3 plus, I have to take this definition, 6x plus 2. So 6x plus 2, if I substitute 3, it will become 20. So LHL is not equal to RHL. So at x equal to 3, it is discontinuous, okay? So f of x is continuous for all the points except at x equal to 3. Hope you understand this one. This is how you will solve all the continuous problems. Okay, let's do next. Find all points of continuity for f of x, which is equal to absolute x by x if x is not equal to 0, and it is 0 if it x equal to 0. Okay, so yeah, let's find out. It is completely defined. Domain is everything, right? Complete R is its domain. Okay, for x is less than 0, okay, only problem we will face is that x equal to 0. Okay, rest all we know that it is nothing but either minus x, either minus 1 or 1, correct? So at x equal to 0, we need to check, correct? So let's see. For x equal to less than 0, f of x is nothing but minus 1. This is a constant function and continuous at x equal to less than 0. For x is greater than 0, we know that it is x by x, which is 1. This is also constant function, continuous, for x is greater than 1. Now we need to check at the boundary condition, which is x equal to 0. At x equal to 0, LHL is x tends to minus 0 minus, which means it is minus 1, correct? Which is absolute x by x. Absolute x will become minus x, so it is minus 1. RHL is absolute x by x, where absolute x is nothing but x, because it is x is 0 plus. So this is 1. So LHL is not equal to RHL, so it is a continuous at all points except at x equal to 0. Okay, next. Yeah, this is also exactly similar. Yeah, similar one. Only thing is the definition of function is x by absolute x, absolute x. Okay. So it will be, you need to solve it same way. Only difference is here at x equal to 0, LHL is nothing but x by absolute x, which is minus 1. Okay. And RHL equal to, for x is 0 plus, RHL is defined as minus 1. Okay. Not as 0 as in the previous question. So which means RHL is also minus 1. And f of 0, which is definition f of 0, this one only, because it is x is greater than or equal to 0. Okay. So f of 0 also minus 1. So LHL equal to RHL equal to f of 0. So this is continuous at x equal to 0 also, which means f of x is continuous at all real values. Okay. So this is the only small change from the previous question. Next. Okay. Find all the points of continuity for f of x, which is defined as given here. So only point of contention will be at x equal to 1. Rest all we know that both are polynomials, so they are continuous. Correct. So let's check at x equal to 1. Okay. LHL is nothing but limit extends to minus 1 minus. 1 minus means I need to take this definition, x square plus 1. Okay. If I substitute x equal to 1, I'll get 1 plus 1, which is 2. RHL is limit extends to 1 plus x plus 1. X plus 1 means because I have it is 1 plus, so I need to take this definition, x plus 1. So x plus 1 is nothing but 2, and f of 1 is also 2. So f of x is continuous at all real values. Next. Okay. Similar to the above one, you need to check the point of discussion at x equal to 2. That's it. Rest all we know that it is already continuous at because both are polynomials. X cube minus 3 and x square plus 1 both are polynomials, so they are continuous. Point of contention is x equal to 2. You check at x equal to 2. At x equal to 2, LHL is 5, RHL is 5, f of 2 also at 5, so it is continuous at all real values. Okay. Next. Okay. Here also point of contention is at x equal to 1. Otherwise, this is the polynomial, this is the polynomial, they are continuous. Correct. So check at x equal to 1. LHL is nothing but 0, but RHL is 1. Okay. So, and f of 1 also 0. So this is continuous at all real values except at x equal to 1. That is, continuity domain is r minus 1. Okay. Next. Okay, again f of x is defined as x plus 5 and x minus 5. So individually they are continuous, we know. Okay, now point of contention is at x equal to 1. So at x equal to 1, LHL is 6, RHL is minus 4. Okay, f of 1 is 6. So definitely LHL is not equal to RHL, so limit doesn't exist. So f of x is not continuous at x equal to 1, but rest all real values it is continuous. Next. Okay, this is a constant function for three different ranges. Okay, so f of x equal to 3 if it is x is less than or equal to x, less than or equal to 1. Okay, less than or equal to 0, less than or equal to x, less than or equal to 1 means between 0 and 1 it is 3, between 1 and 3 it is 4, between 3 and 10 it is 5. Okay, so now where is the point of contention? Point of contention will be at 1, x equal to 1 and x equal to 3. These 2 points we have to check. Okay, so at x equal to 1, LHL is 3, RHL is 4, so there it is discontinuous at x equal to 1. Simple, we don't need even f of 1. At x equal to 3, LHL is 4, RHL is 5, so they are again discontinuous at x equal to 3. So f of x is continuous from 0 to 10 minus 1 comma 3. Only at 1 comma 3 they are discontinued. Okay, next. Again, exactly almost a similar function. Okay, similar to that. So where is the point of contention? First you check that. X is greater than, sorry, this is x is less than 0, I think. It should be x less than 0. This should be reverse. Okay. So x is less than 0. It is 2x. Between 0 and 1, it is 0. And x is greater than 1, it is 4x. So point of contention is at 0 and 1. Correct. So at x equal to 0, LHL is nothing but 0. Okay, because for LHL I will take x tends to 0 minus, which means it is 2x, which is 0. RHL is x tends to 0 plus, so I will take 0, which is 0. F of 0 also at 0. Okay, so which means it is continuous at x equal to 0. This is not 1 actually, sorry, this is a mistake. Okay, this is 1. This is sorry, 0. Okay, and this is definitely other way. Okay, now at x equal to 1, LHL is 0, RHL is 4. Okay, 4x, right? So it is 4. And f of 1 is 0. So definitely LHL is not equal to RHL. So it is discontinue at x equal to 1. So fx is continuous from minus infinity to infinity. That means r minus 1. Okay, which means discontinuity at x equal to 1. Next, find the point all points of continuity for f of x with the definition minus 2 if it is x is less than or equal to minus 1, 2x if x is between minus 1 and 1 inclusive, and it is 2 if x is greater than 1. Okay, again if you check individually they are continuous, right? Within their defined ranges they are continuous, there is no problem with that. Okay, problem is only at contention of points of contention, which is minus 1, x equal to minus 1 and x equal to 1. Okay, this is where definition is falling on two different definitions, right? So different values. So we need to check x equal to minus 1 and x equal to 1. Okay, so at x equal to minus 1, LHL is minus 2 because it is x tends to minus 1 minus, so less than minus 1, which is nothing but this value, correct? Minus 2, which is a constant function. RHL is 2x if x tends to minus 1 plus, RHL is definition is 2x, so 2x is nothing but minus 2, f of minus 1 also minus 2, so LHL equal to RHL equal to f of 1, so continuous at x equal to minus 1. At x equal to 1, okay, LHL is 2, RHL is 2 and f of 1 is 2. What are the definitions you have to take? For LHL, x tends to 1 minus, which means it is 2x. This definition will take. For RHL, we will take x tends to 1 plus, so we will take this definition because x is greater than 1. Okay, so it is continuous at x equal to 1 also. That means f of x is continuous at all the points minus infinity to infinity. Okay, next. Find the relationship between a and b so that the function f of x, okay, equal to ax plus 1 if x is less than or equal to 3, bx plus 3 if x is greater than 3 is continuous at x equal to 3. So this is another type of question which you will get in limits continuity. Okay, they will tell that this given definition of function is continuous at all at given point, then find out the variables a and b. Okay, something like this. This is another type of question. Okay, now it is given that at x equal to 3 it is continuous, so LHL is nothing but limit x tends to 3 minus. If x tends to 3 minus, definition is ax plus 1, so ax plus 1 which is nothing but 3a plus 1. RHL is limit x tends to 3 plus, so definition is bx plus 3, so it is 3b plus 3. F of 3 is 3a plus 1. Now we know that it is continuous, so LHL equal to RHL equal to f of 3. Okay, so 3b plus 1 equal to 3a plus 1, which implies 3a minus 3b equal to 2 or a equal to b plus 2 by 3. Okay, now this is the relationship between a and b. If you satisfy this relationship, then this function is continuous at x equal to 3. Okay, so what is the relationship required between a and b, which is a equal to b plus 2 by 3. Okay, so this is the type of questions you will get, second type of questions in continuity. Okay, for what value of lambda is the function f of x equal to lambda times x square minus 2x for x less than or equal to 0 and 4x plus 1 if x is greater than 0 is continuous at x equal to 0. What about the continuity at x equal to 1? Okay, so let's examine both. At x equal to 0, LHL is nothing but lambda x square minus 2x, which is 0. At RHL is 1, f of 0 is 0. LHL is not equal to RHL irrespective of value of lambda, correct? Whatever is the value of lambda, LHL is never going to be equal to RHL, which means limit does not exist. So it is always discontinue at x equal to 0. Okay, so it is not possible. First of all, whatever is the value of lambda, continuity at x equal to 0 is not possible. And x equal to 1, what happens when x equal to 1, f of x definition is 4x plus 1. This is the polynomial function, so it is continuous. Okay, so that's the answer. Next. Yeah, this is the same one which we did, I think just got repeated. Okay, next. Show that the function defined by g of x equal to x minus gif of x is discontinuous at all integer points. Okay, bracket, that square bracket x is called the greatest integer function, or gif we call it. Okay, so let's do it. Let's see c be the integer. okay, at integer value, at c be any integer, okay. I am not taking a specific value, okay. C is any integer. For limit extends to c minus x minus gif of x is nothing but c minus 1, because it is slightly less than c x is. So this function gif of c minus is nothing but c minus 1. It will go to the previous integer value, correct? So c minus 1, which is 1. RHL is nothing but limit extends to c plus x minus gif of x, which means it is c minus c. It is c plus, so this will always fall under c integer value, which is 0. Okay, so f of c we don't need to worry now too much, because LHL is not equal to RHL. So whatever is the value of c, that means every integer value, okay, at every integer value it is discontinuous. Hence g is always discontinuous at integral values. Okay, next is the function f of x equal to x square minus sin x plus pi is continuous at x equal to pi. Okay, so let's understand this. If you look at the function, x square is a polynomial which is continuous, sin x is a trigonometric function which is continuous, 5 is a constant function, continuous. So x square minus sin x plus 5 should be continuous at all values. Okay, let's see. Okay, so this is what my f of x. Okay, f of x is nothing but x square minus sin x plus 5. Second. Okay, f of x equal to x square minus sin x plus 5, which is equal to g of x plus k of x. Let's say g of x is x square plus 5, k of x will minus sin x. Okay, now g and k are polynomial and trigonometric functions, so both are continuous. So g plus k equal to f also continuous at all points. F of x is continuous at x equal to pi. Okay, so this is the explanation which we can easily tell this is continuous. But if you want to really try, LHL is nothing but limit extends to pi minus, okay, which is nothing but pi square plus 5. RHL is limit extends to, sorry, pi plus, this is pi plus, okay, so which is also pi square plus 5, and f of pi also is pi square plus 5. So LHL is equal to RHL equal to f of pi. So f of x is continuous. Okay, so you can do both ways. Both are okay. Okay, next. Discuss the continuity of the following functions: f of x equal to sin x plus cos x, sin x minus cos x, and sin x into cos x. Okay, so we don't need to actually solve this by LHL RHL method. We know that sin x is continuous because it's a trigonometric function for all values of x. Cos x also continuous for all values of x. Okay, so f of x plus, if you call sin x as g, and cos x as k, then g plus k is continuous because both are continuous. G minus x also will be continuous. G into k also continuous, correct? So we can just explain very easily using the algebras of continuity. Okay, next. Discuss the continuity of cosine, cosecant, secant, and cotangent. Okay, so let's see one by one, then you can do for others. Let's take cos x. Cos x domain is minus infinity to infinity. Let's say c belongs to R and the limit extends to c of cos x. Okay, for x equal to c plus h, where h tends to 0. Okay, this is nothing but your RHL, right? Okay, so limit h tends to 0, cos of c plus h, which is nothing but cos c by definition of cosine a plus b, right? Cos c cos h minus sin c sin h. Okay, if you substitute h equal to 0, what is that you will left with? Only cos c. So f of c equal to cos c, correct? So f of c is equal to limit x tends to c cos x, which is equal to cos c. All are same. So it is cosine is continuous for all real values. Similarly, you can do for cosecant x. Only thing is cosecant x is nothing but 1 by sin x. Okay, so wherever sin x is 0, limit is not defined. You are in the indeterminate form, 1 by 0 form, correct? Okay, so for x equal to c plus h, okay, c plus h, and h tends to 0. Okay, limit h tends to 0, 1 by sin of c plus h, which is nothing but 1 by sin c cos h plus cos c sin h. Okay, now if I substitute 0 here, h, okay, this is 0, this is 1, So I am left with 1 by sin c, which is cosecant c. Correct? So f of c equal to cosecant c. So since f of c equal to limit of x tends to c cosecant x, which is also cosecant c, it is continuous for all values of r except where sin is 0, which is n pi. Correct? So domain is r minus n pi, and in this domain it is continuous. That's it. Okay. Similarly, you can do for secant x. Okay, for secant x, it is continuous at all points of r minus 2n plus 1 pi by 2. Okay, wherever cos is 0, basically. Cot x, for cot x, you have to check wherever the sin x is 0, it will be not defined. Function is not defined. So cotangent is continuous for all r minus n pi. Okay. Next point of all discontinuity for f of x equal to sin x by x if x is less than 0, x plus 1 if x is greater than or equal to 0. Okay, so we know that we need to check only the point of contention, which is x equal to 0. Correct? Rest all we know that sin x is a continuity, x is a continuity, so sin x by x is a continuous function, x plus 1 also polynomial, so it's a continuous function. Okay. So let's check at x equal to 0, what happens? X equal to 0, f of 0 is nothing but 1. Now LHL is limit x tends to 0 minus. So when it is 0 minus, f of x definition is sin x by x. So limit x tends to 0 minus sin x by x. We know that from sandwich theorem this is 1. Okay. Now this is 1. RHL is limit x tends to 0 plus f of x. So I should take definition of x plus 1. Okay, so limit x tends to 0 plus x plus 1, which is also equal to 1, which means LHL equal to RHL equal to f of 0. So f of x is continuous at x equal to 0. So f of x is continuous for all points in its domain. Okay, next. Okay, determine if f defined by f of x equal to x square sine 1 by x if x is not equal to 0, 0 if x equal to 0 is continuous function or not. Okay, this is a very, very important question actually, and very important thumb rule to remember for this one, not only for continuity, also for differentiability, but we will discuss same thing, differentiability of this one when we go to differentiation. Okay, differentiability. So let's check this one. We know that x square is a continuous function. Sine of a 1 by x for x not equal to 0 also continuous. So x square into sine of 1 by x is continuous. Okay, in the domain where x is not equal to 0. Okay, this is a constant function, so we don't need to mention it is continuous. So only point of contention is x equal to 0. So at x equal to 0, f of 0 is 0. Correct? F of 0 is 0. For LHL equal to RHL, both are same basically, because if it is x tends to 0 minus or 0 plus, I am going to take x definition as x square into sine of 1 by x. Correct? So I just took limit x tends to 0, x square sine of 1 by x. Okay, which is equal to 0. Why it is 0? Okay, sine of 1 by x, we know whatever is the angle, sine is always between minus 1 and 1. It is the oscillating function between minus 1 to 1. Correct? And you are multiplying that with x square, which is 0. So it will be 0. Okay, so this limit is 0. LHL equal to RHL equal to f of 0, which is 0. Okay, so which means this is continuous at f of 0 at x equal to 0. Okay, and of course we also know that it is continuous at all other points also. Okay, so it is continuous at all real values. Now as a rule of thumb, you have to remember this function continuity. It is very important. Okay, if f of x is defined in x to the power of p sine of 1 by x if x is not equal to 0, and 0 if x equal to 0, this is continuous at x equal to 0 for all p greater than 0. If p value is 0, only then it is discontinuous. Okay, if p is greater than 0, then it is always continuous. Okay, this is one thing you should remember. Okay, when we can go to differentiability, we will know that if p is greater than 1, it is differentiable. Between 0 and 1, it is continuous but not differentiable. Okay, so remember this one. This is a very important one. Okay. Examine the continuity of f defined by f of x equal to sin x minus x if x is not equal to 0 and minus 1 if x equal to 0. I think you can do it very simple. Only point of contention is x equal to 0. Otherwise, it's a continuous function. Okay. So at x equal to 0, LHL equal to RHL will be same because only thing you are looking at is limit. Okay. Limit extends to 0. Sin x minus cos x, which is nothing but minus 1. F of 0 also minus 1. So LHL equal to RHL equal to f of 0, which is equal to minus 1. So it is continuous at all points of R. Okay, all real points. Okay. 26th, find the value of k so that f of x is continuous at the indicated point. Okay, that is in this case it is x equal to pi by 2. It is continuous. So find out the value of k. Okay, so this is the other way of asking questions I told you. So let's find out the k value. We know that at x equal to pi by 2, LHL equal to RHL because they mentioned it is continuous and also limit exists. So limit extends to pi by 2. K cos x by pi minus 2x is this limit exists. But if I substitute pi x equal to pi by 2, this is in the 1 by 0 form. Correct? Since limit exists, okay, go and apply L'Hospital rule. Okay. L'Hospital rule is k cos x, it will be minus k sin x divided by minus 2. Limit extends to pi by 2. Now, if I substitute pi by 2 here, this is nothing but k by 2. Okay. And k by 2 is equal to 3 because f of pi by 2 is 3. F of pi by 2 is 3. LHL equal to RHL, which is k by 2, which is equal to f of pi by 2, which is k by 2, which is 3. So, k by 2 equal to 3 or k equal to 6. Okay. This is how you'll find out the constant values. Okay. Next. This is also exactly similar. You can do it yourself. The k value is 3 by 4. Okay. Next. Yeah, this is also similar to that one. K value you will get is minus 2 by pi. Okay, because function is already given, it is continuous at a given point, that is x equal to pi in this case. Next, also similar to that one. Okay, f of x is defined as kx plus 1 for x less than or equal to 5, 3x minus 5 x is greater than 5 and x equal to 5 we need to it is given that it is continuous, so find out the value of k. Okay, so k is 9 by 5. Okay, you can do it yourself. This is also okay. Here in this case, you need to find not only k, you need to find two variables a and b. Okay. So since it is continuous at all points, let's check the point of contentions, which is 2 and 10. Correct. So at x equal to 2, LHL is nothing but 5. Okay. RHL is 2x plus b. Sorry, this is 2a plus b. Okay. 2a plus b. So one equation I'll get is 2a plus b equal to 5 because LHL equal to RHL it is defined continuous at all points. Okay. Now at x equal to 10, LHL is 10a plus b, RHL is 21. Okay. So 10a plus b equal to 21. Now I have two equations, two variables. I can solve them. I'll get a equal to 2 and b equal to 1. Next. Function defined by f of x is continuous function. Okay. So this is simple. You can use graph of x, right? Where g and f are continuous functions, then graph of x also continuous, correct? So let us take, let's call g of x as cos x and h of x as x square. So g of h of x is nothing but g of h of x. Okay, so h of x is nothing but x square. G of x square is nothing but cos x square. Now we know that this is a continuous function. It's a simple trigonometric function, continuous. H of x also is x square, which is a polynomial, which is continuous. So g of h of x also continuous in that sense, right? So we can tell this is a continuous function. Domain is same as g and h, which is R. Okay, this is also exactly similar one. We can easily prove that this is a continuous function. Okay, by the same explanation as above. Okay, this is also exactly same. You can easily define using the same explanation, exactly same explanation. You can do it yourself. Yeah, this is one thing. Actually, it is same, but we can do it. Find all points of discontinuity. In this case, we need to find the points of discontinuity. Okay, given by f of x equal to absolute x minus absolute x plus 1. Now, he did not given any range, domain, nothing. So what are the points you will go and check? You will check every point. That is not possible. But you know that absolute function, modulus function changes only when it is 0 plus and 0 minus, you will get a different values. So that means if x is at 0, okay, if x is 0, this limit will give you different values for 0 plus and 0 minus. Similarly, when x plus 1 is 0, which means x equal to minus 1, at that point also, if x equal to minus 1, then you go plus and minus, okay, right and left, you will get two different values, correct? So you need to, your point of contention is only 2 points. One is x equal to 0, other one is x plus 1 equal to 0, which means x equal to minus 1. Okay. So I need to check only these 2 points, x equal to 1 and x equal to 0 and x equal to minus 1. Okay. And now first thing is I will clearly define my function with a range now. F of x is nothing but minus x. Okay. If x is less than or equal to minus 1, what happens? This is minus 1. This is minus x minus 1. Correct. So minus x minus of minus x minus 1. Okay, this is for x is less than or equal to minus 1, which is nothing but 1. Okay, now for x is between minus 1 and 0, this will become minus x because this is still negative, so minus x, but this is positive, correct? So this will become minus of x plus 1, which is nothing but minus 2x minus 1 if x is between minus 1 and 0. Similarly, for x greater than or equal to 0, both are positive, so x and x plus 1 only, x minus x plus 1, which is minus 1 for x greater than or equal to 0. Now at point of contention are only this minus 1 and 0. So at x equal to minus 1, LHL is minus 1 minus, which is nothing but less than minus 1 is 1. Okay. So 1. RHL is also uh, f of x minus 1 plus. Okay. That means I have to take this definition minus 2x plus 1. So if I substitute x equal to minus 1, I'll get same thing 1. Okay. And f of minus 1 is also 1. Okay, so which means LHL equal to RHL equal to f of minus 1. So hence it is continuous at x equal to minus 1. Okay, so 1 is clear. Now at x equal to 0, similarly you can check. You will get at x equal to 0 also it is continuous. Okay, which means f of x is continuous at all the points. There are no points of discontinuity for this one. Okay, this is how we should do these modulus functions. And the first thing is, most important thing in this one is writing this definition. Okay, then which are the points of contention for you? Okay, you cannot go and check all the points, correct? You have to check point of contentions for modulus. You take that modulus value and equate it to 0, then you know you'll get it. Okay, x equal to 0, x plus 1 equal to 0. That's it. These are the point of contentions for you. Okay, so this is how you will do these problems. Yeah, that's all in the continuity. Next video I'll make differentiability, which is same chapter actually in NCERT class 12th chapter 5 only. Since it is a very lengthy video, I just want to break it into multiple parts actually. Okay, next video I'll make about the differentiability. Till then, keep practicing maths. Thank you.